This is the crushing cans experiment. Now this experiment can be a bit dangerous, so remember you do this with grown-ups around, keep it safe, and if you do exactly what I tell you to do, you'll be absolutely fine. What you're going to need is somewhere to heat a tin can on. We're using a small cooking unit here, as you can see, and I'm going to use that ring that's actually on now, and it's very hot, and I'm going to touch it quite yet. You need an aluminium can. This is a drinks can. Empty it out because we're going to be using this. You need a baking tray with cold water. Now you should be able to see in here, I've got lots of water and there's ice floating around in there. You want it iced water, okay? Nice cold water. Some oven gloves, don't you dare laugh at the pattern. So you also need a little bit of hot water to get going. Now on the floor, I've got a kettle, and in a second or two, I'm just going to boil a little bit of water, and I'm just going to pour a little bit of boiling water in here, only about a tablespoon, hardly any actually. You could put cold water straight in and just heat it up on the cooker there like that, but using heated water just is quicker, so that's why I'm doing it, okay? So I'm going to just bring that back to the boil. Just a second, and then very carefully, remember, I'm just going to pour a small amount into that can. Okay, very sensibly, very carefully. Remember, only a tiny amount, you don't need much. That should do, hardly any. And then you put it on your cooker and heat it up. Now notice I did that fairly quickly, that's hot. Be very, very careful with the heat. What I now need to do is bring that back to the boil. And what we need to do is bring it back to the boil, and hopefully I'll have a listen, you should be able to hear it as well when it starts bubbling. And when it starts bubbling in there, we should see lots of what we call steam coming up out. We need to wait for that. By the way, did you notice what I just said then? What we call steam. Actually, what we see isn't steam. Steam's invisible. When you boil a kettle, you see a lot of that stuff coming out. That's not steam. The steam is invisible. If you actually look at a kettle boiling, just where the spout opens out, that's clear usually. When it's boiling furiously, there'll be a little gap which looks totally clear and see-through. That's steam, you can't see it. What you see is where the steam comes out, hits the air, and gets colder, and turns into millions or many hundreds and thousands of tiny little drops of water. And we see them all clustered together, and that's a cloud. That's what you're actually seeing. Now it's beginning to go, as you can see. I can hear it bubbling away in there. It's bubbling away. What we need to do is bring it back up to temperature and let it bubble away for about 1 minute. Now what we're trying to do here is use the water vapour that's being made and that stuff there, we'll call it steam for the moment. All the steam will push the air out that was in the can originally. We want it to push the air out, and there's a clue about how this works. We're going to push the air out with the steam. But it's best to let it go for a minute or so while it does it. And it's only just about boiling a teeny bit. I can only hear it bubbling a bit, so I'm going to let it run for a minute or so. And when you've done this, after a minute or so, what I want you to do, or someone to do it with you, is put on your beautiful oven gloves. I'm going to describe what I want you to do, and this is what I want you to do, okay? I want you to very carefully and sensibly grab the can, very carefully take it and turn it upside down, and put it upside down into the ice water and see what happens. Okay, so it's been going now for a minute or two. Let's see what happens. So, why did that do what you saw it do? Couple of safety things. I'm sure I don't need to warn you about being very, very careful with heat. There's a lot of heat here. There was a lot of heat coming out of that kettle. Please be sensible with this one. And definitely have grown-ups around whatever way you do it. When I took the can off here, I just lifted it and turned it straight over. I didn't turn my cooker off. when you do this, particularly if you do it at home, always turn the cooker off first. The reason being, you might forget, because I've got a bad memory sometimes, and I might have gone and done that experiment, forgotten and left the cooker on, and then something awful could happen. So always turn that off first before you lift it. You've got time, that's no problem. So what was going on? When we had the can on the ring there being heated, you saw the water vapours coming out. The water vapour is actually what we often call steam, was smoking out the top of the can. And remember what I said? What I was trying to do was use that as it was boiling to push the air out that was inside the can. It was pushing the air out. And of course it was getting very hot inside the can at the same time. And leaving it a minute or so is probably best. It would have done it at different times, but that's something you can try. But a minute's good. Then you saw me take it very carefully in my good strong gloves with a lovely design, and then I quickly turned it upside down into the water. You saw all this, and hopefully you've done the same. And then we saw this happen to the can, which of course has cooled right down now. It's been in ice water. And look at that, wonderful, isn't it? Brilliant, the way it's crushed it like that. Well, it might surprise you to know that what was crushing it was the air outside. It's the air that did that. Because as soon as we turned it upside down and put it into the cold water, suddenly we cooled it down inside as well. Suddenly the temperature dropped tremendously inside, and on the outside too actually, but we're thinking about the gap inside. And all the gas that was trapped inside suddenly got cooled down, and when things cool down, they contract, they shrink in size. So it got cooled down really quick by the ice water, shrunk inside, and of course when it shrunk it needed less space. And it was therefore having a suction effect. It was like sucking in. But that suction effect was actually caused by the air outside, because the pressure of the air around us is always pushing on us. It's pushing on us now. It was pushing on that can even when it was here. But when we suddenly drop the pressure inside, the pressure outside pushes on and just collapses it in. So you can see the effect of ordinary air pressure around us in this room right now, pushing against the can and crushing it. Of course, it doesn't normally happen like that, because the pressure inside is usually similar to outside. When it's open, it's normally the same. But what we done made it drop really quickly, because it got so cold in there, and suddenly the tiny bit of gas that was left suddenly shrunk to a tiny volume and caused the air outside to push and squash the can flat. And you saw how quickly it happened, almost immediately, didn't it? It crushed, it even fell out of my hand. It was so aggressive what it did. Amazing stuff. So what other things could we change to see what's going to happen? Well, your imagination I'm sure is as good as mine, but let me give you a few suggestions. How about we use the same sort of can, but instead use more water at the start. So maybe put a quarter of a can of water, for example. Remember, I only poured a tiny bit in. You couldn't really see how much I poured, but you did see it wasn't very much. But how about put a lot more? Will that make a difference, do you think? What about using a different type of can? This is an aluminium can. I wonder if you could find a steel can and do it with a steel can, because we make cans out of different materials. Would it make a difference? So that's an interesting one too. What about if we didn't boil the water in the way we did here? For example, you saw me take boiling water out of the kettle. We just poured that water in and we used that. Do you think that would work? What about if we didn't put any water in it at all? Maybe if we just took the can and heated it on the ring just for a few seconds. I wonder what that would do. But don't leave it very long if you do it that way. What about different size cans? Of course, this is only one size. They come in different sizes to this, don't they? So I wonder what would happen if we used maybe one of those tall cans you can sometimes get. Would it still work? Would it make any difference? Would it crush differently, even if it does crush? If we get a tiny can, I've seen these little cans. Sometimes when you go on aeroplanes, they give you these little mini tin cans, don't they? I wonder if it'll work with those, because you see them in supermarkets sometimes. I wonder if you can use one of those little cans. I wonder if the temperature of the water would make a difference. We used ice water. What about if we didn't use ice water? What about if we just used ordinary room temperature water? What about if we used very hot water, actually? Make sure it's not so hot that you'll burn yourself, of course, but hot water you could touch. But use hot water, will it make a difference? Or even colder? Could we get it even colder, I wonder? That's something for you to think about. Different size container. I've used a pretty big tray here, haven't I? I wonder if it would work in half the size. Do you think it would still work if we did that? I'm sure you can think of some other things too.